Hey everyone, as a senior AI engineer, I am absolutely thrilled to guide you through the complete journey of evaluating generative AI and RAG applications for production. We're going to look right under the hood of enterprise-grade AI systems, to understand exactly how we measure, monitor, and optimize them in the real world.
All right, so let's just dive right in by acknowledging a pretty massive shift in our industry. You simply cannot grade a non-deterministic creative system using the exact same metrics you'd use for a deterministic classifier. I mean, think about it. If you ask a traditional model to classify an image as a cat or dog, it's either right or wrong, boom, done. But if you ask a large language model to summarize a 50-page financial report, it's going to generate a completely novel text sequence every single time.
Here's our roadmap for today's explainer. We'll kick things off with why we need to evaluate GenAI in the first place, map out the RAG architecture, and then dive deep into evaluating both retrieval and generation quality. Finally, we'll wrap up with system safety, efficiency, and how to actually scale this stuff responsibly in the enterprise.
Okay, part one. Why do we even need to evaluate GenAI? And why do we have to move beyond our traditional ML metrics?
So, traditional AI outputs a rigid label or a score, right? But generative AI, it generates statistically plausible novel content. And honestly, plausible is kind of the dangerous word there. In complex contexts, like medical or legal queries, ungrounded LLMs can literally have up to an 82% hallucination rate. They are just confidently lying to you token by token. We really need metrics to automatically detect when that assembly process goes completely off the rails.
Moving on to part two, the RAG pipeline architecture, where we'll map out the actual evaluation journey.
All right, so here's the core RAG workflow we all know and love. We break documents down into manageable chunks, embed them into a high-dimensional vector store, retrieve the relevant context, and then pass it to the LLM. Now, because this is a multi-step pipeline, our evaluation absolutely has to isolate the retrieval layer from the generation layer. If you get a bad answer, you need to know immediately, did the database fail to find the right document, or did the LLM just fail to read it correctly?
Now, zooming out for a second, a true enterprise production architecture isn't just a basic vector database in an LLM. The whole shebang includes human interaction, intent routing, and real-time content moderation. You need an evaluation layer that integrates directly into your observability dashboard to create this continuous, automated feedback loop.
All right, part three, evaluating retrieval quality. Basically, did we actually find the right data?
Let's talk about context precision. This measures whether your vector database and re-ranker are actually prioritizing the most pertinent chunks for the LLM. And why does this matter to you? Well, if precision is low, you're just flooding the context window with irrelevant noise. That spikes your hallucination risks and burns through expensive API tokens for absolutely no reason. On the flip side, we have context recall. This ensures your system isn't systematically missing crucial pieces of evidence that the LLM actually needs to answer the query accurately. If your recall is low, your LLM simply doesn't have the facts required to give a correct response. So together, precision and recall tell you exactly how well your embedding models and chunking strategies are actually performing out there.
Moving to part four, evaluating generation quality. Once we have the data, is the answer actually correct and grounded?
Okay, here is the fundamental rule of GenAI evaluation. We don't just measure the final response against the initial query. No way. We have to measure the generated response against both the retrieved documents and a sample ground truth. This kind of multidimensional check is what allows us to accurately score relevance, correctness, and comprehensiveness.
Let's look at faithfulness, which you'll sometimes hear called groundedness. This is arguably your absolute most important defense metric. A low score here immediately flags a hallucination, meaning the model invented, misattributed, or just completely hallucinated information that was nowhere to be found in your retrieved enterprise data.
Then there's answer relevance. This ensures the LLM didn't just generate some highly factual, totally faithful summary of the documents that completely ignores the user's actual prompt. I mean, you can have a perfectly faithful answer that is entirely useless to the user if it doesn't actually address their specific question, right?
Take a look at this modern shift in evaluation frameworks. In the past, we really relied on natural language generation metrics, like BLUE or Rouge, which basically just count exact word overlaps. If an LLM uses a synonym, those metrics totally fail. That's exactly why the industry standard right now is the LLM as a judge approach. Frameworks like RAGAS, DeepEval, LangSmith, and TrueLens use powerful models to evaluate semantic meaning, scoring for faithfulness and similarity just like a real human grader would.
Part 5, System Safety and Efficiency. This is all about going beyond just getting the answer right.
So here is a glaring and frankly really concerning vulnerability in the industry right now. Research shows that while roughly 90% of engineering effort focuses on retrieval and generation quality, only a measly 9.1% focuses on safety evaluation. We are literally building these insanely powerful engines, but we aren't installing any seatbelts.
If you want to build a truly enterprise-ready system, your evaluation dashboard has to continuously track these specific safety and efficiency metrics. You absolutely need to monitor for hallucination rates, robustness, bias, and PII leakage to protect user privacy. And from a strictly operational standpoint, tracking end-to-end latency, token usage, and your cost per request, that's non-negotiable. If a RAG system gives perfect answers but takes 45 seconds and costs $2 per query, it's just not a viable production tool.
Finally, Part 6. Enterprise AI Best Practices. Let's talk about scaling responsibly. By following these 4 steps, you can ensure your RAG application has the necessary feedback loops to safely handle real-world dynamic data. You've got to instrument automated evaluation for every code commit, run regression testing on your prompts, and absolutely implement human-in-the-loop review for sensitive outputs. On top of that, red teaming your system against prompt injection attacks is an absolutely crucial best practice before any public deployment.
Ultimately, operational discipline is what separates sustainable AI adoption from those isolated, unscalable experiments. If you treat AI as a magic black box, you are going to fail. As the industry saying goes, you must treat GenAI as infrastructure, because without measurement, optimization is basically impossible.
An unevaluated GenAI system is nothing more than a massive, highly articulate liability. But with the right metrics, tracking context precision, faithfulness, latency, and safety, you can confidently deploy agents and RAG pipelines that drive incredible value. So I'll leave you with this to look at in your own architecture. Are your generative AI applications truly creating value? Or are you just scaling statistically plausible liabilities?